Problems 11 through 34. So let's choose, find the exact value of the trig function. This is an important situation that we have to look at. Okay, there it is. So let's look at 14. Cosine negative 60 degrees. Let's look at something that we talked about. Can anyone remind us the relationship that the function fulfills for any odd and the function fulfills for any even? We wrote it so many times when we graphed rational functions, also when we graphed polynomial functions. What is the relationship? What has to happen for a function to be odd? F of negative x. Yes? Exactly. Please do not forget this. This is very important. For an even function, it has to be the same thing. It has to be, I have to start with the same thing, always. F of negative x. Exactly. Good. These trig functions are all symmetric, all of them. So the odd functions are sine, tangent, cotangent, cosecant. Any function, any trig function that has sine in it, it will be odd. What are the other functions that are even? Cosine. And the other function that has only cosine in it, what function is that? Very good. So if sine, we say it's an odd function, sine of negative alpha must equal, you have to see it here. You cannot invent anything. It's too late for us. We should have been born in the year 100.
I've seen Odyssey, Space Time. But yeah,
So sine negative alpha must equal negative sine alpha. Tangent negative alpha must equal, very good, cotangent negative alpha, and finally cosecant alpha negative alpha must equal. Good. So please remember, all trig functions are odd except two of those that have cosine in them. Everything else is odd. So cosine negative alpha. Nice function. Secant negative alpha. Good. So this is very important again. Like the sign of the trig functions in each quadrant, this is very important to remember. Everything odd except cosine and secant. So when we get the chance to graph them, everything will be symmetric with respect to the origin, and these two will be symmetric with respect to there will not be a function. Something that is symmetric with respect to the x-axis will not be a function. The y-axis, indeed. So let's write that down because we forgot. So symmetric with respect to the y-axis, and here origin. Is that clear why? A function that looks like this, if it's symmetric, if a graph that looks like this and symmetric with respect to the x-axis, is this a function? No. By the vertical line test, is not a function. It's possible for equations or relations. We have, for example, when you get to calculus, we're going to look at something like this. Is this a function? But it's symmetric with respect to the origin, the y-axis, and the x-axis. But it's not a function. Ready?
What makes that?
You will have to see.
Oh.
Wait and see. Okay.
Spoiler alert.
Okay. I just gave you an example, but it's not a function by the vertical line test. Good. Okay, finally, I'm coming back here. I know that cosine is blah or blah.
Oh, it's blah.
That was good.
It's
Okay, which one? Is it odd or even?
It's even.
Good. So then cosine negative 60 equals?
Cosine 60.
Correct.
Yeah.
So I don't have to mess around with a negative sign and going around the circle with a negative angle. That's crucial. That's very important to know. Okay, so then I know what this is. We just discussed it an hour ago. No? Oh, yes, of course. I'm sorry. I was thinking of 30 degrees. I'm sorry. You're right. Yes. You're right. No, you're right. You're right. Sorry. Okay, let's choose another. Do I get to choose?
Yeah.
Okay, I would like to choose 28. Tangent 5 pi over 6. First of all, I have to look at the unit circle for several reasons. Number one, because I don't know where it ends. I don't know which sign it's going to have, because I don't know which quadrant has the terminal side. How much is pi over 6? The first one, the small angle, 30. How much is 30 times 5? Good. So then I know the angle is right here, 5 pi over 6. And I know it's RA. What is the RA? Right, or pi over 6. Perfect. So now be careful. What next? What follows next? What is the sign of tangent in the second quadrant? And this is tangent of pi over 6. It's tangent of RA, but only after I establish the sign. And now you can say, I'm asking you how much is tangent pi over 6, and you should say you didn't ask us to remember this, and that's true. But I asked you to remember that this is sine pi over 6 over cosine pi over 6. And this is the first angle. Sine is? Yes. Cosine is the other number, square root of 3 over 2. And when I flip, I get negative the square root of 3 over 3 after I rationalize. Now, I would like to go through the steps one more time. So, are we done? Can we look at, okay, here are the steps. If the angle is negative, I think in these terms. If I'm given sine, then I will write minus sine 60. But if I'm given cosine or secant, then I have to write directly cosine or secant. In this case, first I established, because it's hard for me to say, what is 5 pi over 6? Where does it land? But I know that pi over 6 is 30. 30 times 5 is 150. So 150 has to end in the second quadrant. Then I easily identify the RA. The next step after I identify the RA and the terminal side of this angle, then I ask myself, okay, now I know it's in the second quadrant. What is the sign of tangent in the second quadrant? Since sine is positive and cosine is negative, tangent ends up being negative. So now it's negative tangent of RA. Because if I ask you about this, tangent 150 degrees, you should say, wait a minute. 150 does not fit into a right triangle. How can you find tangent? Well, I find tangent because these functions are so-called periodic. They repeat themselves. Sine, cosine, tangent, cotangent, indefinitely. So one more time. I establish the terminal side. I find the RA. I establish the sine of tangent. And all I have to do is write tangent pi over 6. Tangent of the reference angle. I copy minus. I don't know what this is, but I know it's this over this. I know this is 1/2. I know this is the square root of 3 over 2. When I flip, I get 1 over the square root of 3, and I have to rationalize. Any questions on this? Okay, let's choose an. Say it again.
The answer to that would be negative square root of 3 over 2. Or it means negative tangent times 6.
But that's it. Negative tangent pi over 6 is negative the square root of 3 over 3. I calculated it. Good. Next question. I think we should work on one more. Please choose one more. So we can continue. Okay, 31. Very good. Cotangent negative pi over 4. I dig deep. I don't want to mess with negative angles. It's a waste of time because I know cotangent is.
It's just going to be, the answer's going to be times negative.
Exactly. So what do I write?
Negative cotangent of pi over 4.
And I'm done. Because pi over 4 is in the first quadrant. This number was going to be positive. With minus in front, it stays negative. So cotangent is cosine pi over 4 over sine pi over 4, because I said don't bother with that to memorize it. But I know that cosine and sine for pi over 4, exactly. The only angle whose sine and cosine are the same. So the answer is, I safely simplify. They're the same. So the answer is,
1, negative 1.
that's it. Ready to move on? Yes? 35 through 38. So which function, three functions are odd?
All the ones that involve cosine.
Cosine or secant. Yes. Very good. So let's choose a problem from 35 to 38.
36.
36 it is. Tangent. So that's page 460. We have the tangent theta is less than 0, and I'm told sine theta is less than 0. From the given information, they only want us to say, oh, theta must be in such and such quadrant. That's all they want, nothing else. So go back to the unit circle. Can anyone tell us where is tangent negative? Second and? Because here they have the same sign. Sine and cosine have the same sign, so tangent has to be positive. Where is sine negative? Careful. Sine is measured on the y-axis. Sine is positive here and negative here. Cosine is positive here and negative here. So sine less than 0 is here and here. I have to choose the only quadrant that fulfills both conditions. So theta must be in 4. That's the only quadrant that fulfills both conditions. Perfect. Okay, you need to choose another one or we move on?
Yeah. We'll do 38.
Yes. 38. Same page. So we have cosecant theta greater than 0, cosine theta less than 0. We go to the unit circle. Let's start with cosine. Where is cosine negative? Yes? Yeah. Third, because it's measured on the x-axis. Good. So what about cosecant? Cosecant has the same sign with cosecant must have the same sign with with sine. Very good. Very good. So where is sine positive? Where is sine is positive, cosecant would be positive.
So that would be,
Sine is measured on the y-axis.
so 1 and 2.
I have to choose the only quadrant that fulfills both conditions given in the problem. Which quadrant is that? So theta in 2. Moving on to the next set. 39 through 44, please. Write the first trig function in terms of the second one.
40.
40. First, I would like you to give me the most important trig identity that we discovered today. Sine squared alpha plus cosine squared alpha equals 1. From here, we established two more. We established that 1 plus cotangent squared equals cosecant squared. And then tangent squared plus 1 equals secant squared. Right? Okay. I'm interested to come back here for a moment. I would like you to walk me through the steps of finding sine alpha. How do I find sine alpha from that? What do I have to do first? I'm solving this equation for sine alpha. Of course. Sine squared alpha equals 1 minus cosine squared alpha. Good. I have to move this term to the other side. It doesn't have the variable. Good. And then I take the square root. Excellent. I take the square root. And what do I get when I take the square root? Careful. I cannot miss something in front. Exactly. 1 minus cosine square alpha. We cannot simplify this. We cannot take square roots from differences. So don't even attempt anything here. Please remember that's crucial. So the square root of a squared minus b squared does not equal the square root of a squared minus the square root of b squared. Please remember that. Okay, good. So now we're back. Now we're looking at problem 40. In problem 40, we're asked to, so it says, write the first trig function. This is what I need to write in terms of the second one, using only sine theta, knowing that theta is in the second quadrant. So, can anyone give us the definition for cotangent theta? Yes, I could write 1 over tangent, but then I need the definition for tangent. Yes? Over? Good. I am told to express cotangent in terms of sine only. So this is okay. But now I have to express this in terms of sine. So I'm going to come back to this relationship. And I want you now not to solve for sine, but solve for cosine. And tell me what to write. So I have, yes, cosine squared. So plus cosine squared alpha equals 1. Cosine squared alpha equals 1 minus sine squared. And then cosine alpha equals, I can't, yes, the square root of 1 minus sine squared. So now coming back here, I have to replace cosine theta by this. However, I have a dilemma. Here's my dilemma. And it can only be one. Which one?
In quadrant 2.
Exactly.
Sine of.
Not sine. We're not talking about the we are changing cosine into this. So exactly. Now this is correct. Indeed, we expressed cotangent in terms of sine only for theta in the second quadrant. Sine is sine, but cosine has to be negative in the second quadrant, so that's why I had to choose minus the square root. Very good. Excellent.
You put the negative in front because it's in the
Because I have to write plus or minus.
right.
And I cannot write plus or minus. If I'm told it's one quadrant, it cannot be plus or minus. Cosine cannot be in the second quadrant plus or minus. It can only be minus. Good. So let's choose another. Ready? Which one?
44.
Okay. So we have cosecant theta. This is what we want to determine. And we can only use cotangent theta for theta in 3. So I only want cosecant in terms of cotangent. Do we have anything a relationship that connects cotangent to cosecant? Do we have anything that we looked at? Do we have any relationship that connects cotangent and cosecant? Exactly. So I'm going to use this, and I will take square roots from both sides because that's what I need, and then I will make a decision. So let's write it one more time. 1 plus cotangent squared theta equals cosecant squared theta. In order to determine cosecant theta, I take the square root and I have to put plus or minus in front. So please remember, there is a relationship that connects sine and cosine, and there is another relationship that connects cotangent and cosecant, and there is another relationship that relates tangent and secant. So now I would like to know which sign. I cannot keep both, because in each quadrant, each trig function has only one sign, not two. So cotangent, so cosecant is 1 over sine, right? So theta is in the third quadrant, and cosecant will have the same sign with sine. Negative indeed. So I will say only negative. So then cosecant theta equals negative the square root of 1 plus cotangent squared. So one more time in summary, please remember sine and cosine are related in a relationship. They have a relationship, an equation. Tangent and the co go together. Secant are related. And cotangent and cosecant are related. So there is an equation that involves sine and cosine. There is a second equation that involves only tangent and secant. And there is a third equation that relates only cotangent and cosecant. Are you okay? Okay, 45 through 52. 45 through 52. 47. Tangent theta equals negative 3/4. Cosine theta is greater than 0. Perfect. Find the values of the trig functions of theta from the information given. Okay. I look at the unit circle That's the first thing. Can you please tell me where is cosine positive? Cosine positive. Exactly. Good. Now I'm looking at tangent. Where is tangent negative? Because I need to establish. If I can't establish where the terminal side is, I can't do anything. So where is tangent negative? 4 and 2. So now I know for sure that theta must be an angle where? Yes. Okay. If theta is in 4, sine theta will have which sign? Cosine theta will have which sign? Tangent is already there, but I'm going to list it again here. Cotangent in the fourth quadrant will have which sign? Right. Can you give me cotangent right away? That's it, with minus. Very good. Secant theta will have which sign? It's 1 over cosine. Positive. So then cosecant theta will be, yes, because it's 1 over sine. Good. So I have to determine 1, 2, 3, 4 trig functions. Okay, good. So I have tangent and cotangent. So let's say I'm looking at tangent first. I have tangent. Is there any equation that involves tangent and one other trig function? And if the answer is yes, which equation that we just looked at 3 seconds ago involves only tangent and one other function? And which function is that? And I need the equation. Yes. Yes, yes. I know it's a lot, so I'd rather repeat it. We have 3 equations that we have to keep in mind. One equation has only sine and cosine in it. This one. This one. A second equation has only cotangent and cosecant in it. This one. And the third equation has only tangent and secant in it. So if we look at tangent, is there an equation that has only tangent in it and one other function, trig function? Yes. Can you dictate that equation?
So it can be tan squared plus 1 equals 6 squared.
Very good. So what I'm going to do is replace tangent squared by negative 3/4 squared plus 1. And that will be secant squared. How much is negative 3/4 squared? Nine sixteenths plus 1. 9/16 plus 1 is 25 over 16. I need just secant, not secant squared. So what should I do? Take the square root from both sides. And there are 2 options. So then secant theta must be plus or minus. Right? However, I go back to my analysis from before. I know theta is in the fourth quadrant. Secant cannot be positive or negative. Can only be we already have established it here. Good. So it's only positive 5/4. If I have secant, what other function follows from there immediately? Right. What is cosine? Very good. If I have cosine, which other function I can determine right away because they are connected within an equation.
It's not.
Exactly. So I know that sine squared plus cosine squared equals 1. I have cosine squared and cosine, but I want to determine sine. What do I do?
Yeah, isolate.
Yes. So I have sine squared theta equals 1 minus cosine squared theta. Like before, I get square root plus or minus this. Now I have already established from the very beginning, so I don't make a mistake. I already established that sine must be in the fourth quadrant, must be negative. So I'll say only sine theta equals negative the square root, and I have cosine, which is 4/5, 1 minus 16 over 25.
It's 25.
25 minus 16. Cosine cannot be a number greater than 1, right? So secant was 5/4, but cosine is 4/5 because it's the adjacent over the longest side of the triangle, so it has to be less than 1. So then 25 minus 16 is 9. So then sine theta equals negative 3/5. Once I have negative 3/5, I have cosecant. How much is cosecant? Negative 5/3. And that's how I determine the function values of an angle given something. We were given, in this case, the fact that tangent was this and the fact that cosine was a positive angle. They didn't want to tell us the quadrant. That's why they gave us this extra information. They gave us tangent, which is negative, and somehow they had to give us some information about theta. And they said cosine is positive, and that's how we figured out cosine is positive here, tangent is negative here, so we picked the fourth quadrant where both conditions are fulfilled. Tangent is negative and cosine is positive. Yes?
So since we know that tangent is opposite over adjacent, or just vice versa, can we just, since it's a triangle, can we just...
You can do that.
It's not the lazy way to do it, but...
No, it's not. So, but just remember, you can do that, but after you establish the signs.
Okay.
Because you may forget about the signs.
Okay.
So once you establish them, you can say, okay, if this is the angle theta, and this is 3/4, this must be 5. But after you establish the signs. Also, the purpose of this exercise for me was to go through these 3 equations because they are super important. They are the fundamental identities of trig. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. But yes, I agree with that. It's perfect.
So you established the signs by the quadrants there?
Yes,
Okay.
exactly. So in the fourth quadrant, sine must be negative. Cosine, I know, is positive. So this ratio must be negative no matter what. And secant is 1/a cosine. If this is positive, this must be positive. And cosecant is 1/a sine. If this is negative, this must be negative. And then you can do this. It's not the lazy way. It's really nice. I just wanted to establish the relationships and go back to the relationship.
Yeah, because I was just curious because like, when it comes to like quiz or test down, would the triangle way just be accepted?
Yes,
Okay.
absolutely. As long as you initially, because from the triangle,
You
you
don't
will
get the
not
signs.
be able to get the signs.
Yeah, no, I got you.
So that's the problem. Unless you do this, and I accept that too.
Okay.
So you have the option of doing this. So the angle ends here. So this is the angle because it has the terminal side in the fourth quadrant. And then you say, right, we had negative 3/4. Very good. So this is the angle, reference angle. So this is negative 3, and this is 4. And from here, then this must be 5. Because this is obtained with the square root of 4 squared plus 9, right? So this must be 5.
Okay.
So then from here you can say, okay, in that case, Sine must be negative 3 over 5. Cosine must be 4/5, and so on and so forth. And I'm okay with that, and you don't have to think in terms of the sine. But you have to establish that this is negative because it's below the x-axis, and this is positive because it's on the x-axis. So that's another option. Good. Anything else here? I know I have just 4 minutes left. Let's go back for a second to 5.1 and 5.2. So you can see that it's exactly the same thing, then we don't have to do anything there. So 5.1. Because I could not wait with a unit circle. We had to, the reference number, which is the same thing, is the shortest distance along the unit circle between the terminal point and so on and so forth. It's the same thing. Okay. Reference number and terminal points. So we can pick a problem from page 376, and everything we just discussed from the beginning is in 5.2. Everything the same. The signs of the trig functions that we just discussed. These relationships that we've been using from the beginning. Even and odd properties which we discussed today. As you see, sine is odd, cosine is even, tangent is odd, cosecant is odd, secant is even, these two are even and odd. The fundamental identities, which we already discussed, all of them, and these three identities. So 5.1 and 5.2, please look at those problems for Monday. It's just reinforcing what we just discussed. Look at these problems. They're exactly the same as we just did. This is the same. Find the values. All the same. So 5.1 and 5.2, you don't have to turn in homework from those, but please look and check the answer in the back. Okay? Because they are identical. So coming back to the syllabus. So here's what we accomplished. And we have 6.3, we have 5.1, and we have 5.2. So between now and Monday, please, it's not a lot. So it's every other odd. You can save in every other second odd. I'm fine with it for these two. But look at those problems.